Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode, we're going to be talking about the Pythagoras Theorem. So in the previous episodes, we talked about the basic proportionality theorem, the Thiele's theorem. We also did some sums regarding, some basic concepts. So if you haven't checked them out, I recommend checking out those episodes because there's a lot of information in them that will be used in the future episodes as well. So in this episode, we're going to be talking about the Pythagoras Theorem. Now, Pythagoras Theorem is a really important concept which will be used really significantly. So yeah, without further ado, let's talk about it. So first of all, what is the Pythagoras Theorem? Now the Pythagoras Theorem states that in a right angle triangle, let's take this as a right angle triangle, the side of the hypotenuse or the square of the hypotenuse is equals to the square of both the other sides. So for example, basically it says that hypotenuse square is equals to base square plus side square. Or here, let's say AC square is equals to BC square plus AB square. Yeah. So this is the formula for the Pythagoras theorem. Now, how would you use them in sums? Well, basically, let's take an example. Let's say this is 3 centimeters and this is 4 centimeters. Now let's put them in the Pythagoras theorem. So first of all, we need to find out the hypotenuse. So AC square is equals to 3 square plus 4 square. So AC square is equals to 3 to 9 plus 16. AC square is equals to 25. AC is equals to 25 whole root. So AC is equal to 5. So this is 5. So that is how you can use Pythagoras theorem in sums. So now, let me take this eraser really quick. Now let's actually try to prove it. So because we are doing all of the sums, we obviously need an explanation to why we use this formula, right? So to prove that we are using this formula and it is correct, we obviously need to prove it. So let us do a sum which is going to prove that the Pythagoras theorem about how Pythagoras theorem works. So obviously to do that we obviously need another theorem, and let's say in a triangle when a line is when a perpendicular line is drawn from the vertex to the hypotenuse, then both of the sides will be similar to each other. So for example, if I draw this line onto the hypotenuse, let's flip this triangle, but basically if we draw it to the hypotenuse, then basically both of these sides will be divided and will be in the same ratio or are similar to each other. So now that we have understood this theorem, now let's actually try to do the sum. So let's see. Okay, so I shouldn't have wrote that, but let's write A, B, C, I guess. Okay, I just wrote something. So now let's actually try to do the sum. So since, like I said, according to the theorem, they are similar, let's say ADB is similar to ABC and BDC is similar to ABC. So now that we have wrote the two similarities of the triangles, now let's actually do something. So let's take AD by AB is equals to AB by AC. On the other hand, let's take something like this. So basically let's take them like this because they are similar, so we can take them in the forms of fractions. So now let's do the cross multiplication. So by doing this, we'll get AD into AC is equals to AB into AB. Now AB into AB is equals to AB square. So instead of writing AB into AB, we can just write it as AB square. We can take this as equation number 1. On the other hand, when you cross multiply this both, you get CD into AC is equals to BC into BC, or you can write them as BC square. So now that we have gotten both of these equations, let's add them together. So AD into AC plus CD into AC is equals to BC square plus AB square, or vice versa, but they're addition, so it doesn't really matter which way it is. So now let's take AC as the common. So AC into, let's add AD plus CD. So now what is AD plus CD? Well, if you see here, AD plus CD is this entire line, AD, CD. So this entire line is, AD plus CD. So basically AD plus CD is equal to AC. So we can write this as just AC. So for example, let's write something like this. So let me continue in the top over here. So basically this means that AC into AD plus CD is equals to BC square plus AB square. So AC into, this will be taken as AC because I just explained it, is BC square plus AB square. So AC into AC is AC square. So AC square is equals to BC square plus AB square. So that is how you prove that a Pythagoras theorem works, or why you use this formula. So yeah, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell to not miss any new videos. And that's all folks, and see you in the next one. Bye bye.